All right, this is a solution video for the warm-up from section 2.6, solving absolute value inequalities. This is our warm-up, and the first part was solving absolute value equations, and the second part was solving compound inequalities. So let's look at the first part. You are to solve each equation and graph the solutions if possible. And these were the 3 problems that you were asked to do in Class Kick. So let's take a look at each one of them. You can pause the video to solve the equations if you're doing this from home, and then restart the video to check your answers to see what you showed your process correctly by watching the next 2 slides. And these are in Class Kick, by the way. So we're going to solve each equation and graph the solutions if possible. So the first one, we have absolute value of x minus 4 equals 6. So remember that we're looking at the definition of absolute value, where we want to find a value of x that is 6 units away from 4. Let me get my laser pointer. So 6 is the distance away from our center point. So the center point is 4. It's the difference between some number x and 4. So it's not negative 4, it's 4. That's the center point. And so what we want to do is consider the expression x minus 4. And out of our 2 cases, we're going to separate it out. We have the distance away to the left, which is negative 6, and the distance away to the right, which is positive 6. So we're going to write the 2 related linear inequalities. We have x minus 4 equals negative 6. That's our going to the left of our center point. Or x minus 4 equals positive 6 going to the right of the center point. And then we solve each equation by adding 4 to each side. Add 4 to negative 4 is 0. Negative 6 plus 4 is negative 2. And then the other linear equation, we're going to add 4, and we get x equals 6. So our solutions are x equals negative 2 and x equals 6. So those are the 2 values that are 6 units away from 4 on the number line. And we can see the number line. Here's our center point of 4. And we go 6 units to the left, which gives us negative 2, and 6 units to the right, which gives us positive 10. Notice this is a scale of 2 on the number line. Okay, so our second equation, we have absolute value of 3x plus 5 equals negative 5. Well, because the absolute value of an expression must be greater than or equal to 0, since the absolute value represents a distance, and a distance is a positive number, then the absolute value expression can't be equal to a negative number. So there is no solution. This equation has no solution. So let's look at our third one. We're going to solve absolute value of 3x plus 9 minus 10 equals 4. So the first thing we need to do is isolate that absolute value expression, which means we'll need to add 10 to both sides. If we add 10 to the right side, we get negative 4 plus 10 is positive 6. And now we have the expression with the absolute value isolated on the left side. And it is now time to separate it and write as 2 linear equations showing that we have an expression, and we'll have the expression, we're going to look at the distance away as being 6 to the left and 6 to the right in separating it out. So remember, you just take the expression from inside the absolute value bar and bring it out. So it's 3x plus 9 equals negative 6, or you take that same exact expression, 3x plus 9 equals positive 6. So take out the inside, it's equal to negative 6. Take out the outside, it's equal to positive 6. And then we have 2 equations we need to solve. So we're going to subtract 9 from both sides here, and we get negative 6 minus 15, minus 9 is negative 15. And our second equation, we'll subtract 9 from both sides, and we'll get 3x equals negative 3. So now each one needs to still have x isolated, so we're going to undo the multiplying and divide 3 from both sides. So if we divide 3 from both sides in the first equation, we get x equals negative 5. And if we divide 3 from both sides of the second equation, we get x equals negative 1. So our 2 solutions are x equals negative 5 and x equals negative 1. Okay, so now the second set of questions that you did in Class Kick, solving compound inequalities. So you're going to solve the compound inequality with and graph the solution if possible. So the first type, we have the expression where the variable is in between the two inequalities. And then the second problem, you're solving the compound inequality with OR, and then we're going to graph the solution if possible. So the second problem is two separate inequalities that are separated by OR. We have two separate inequalities that you will solve individually. So if you're doing this by video, you'll pause, do it in Classkick, and then come back to watch the solutions. And then that show up in the next two slides, and you want to make sure that you're paying attention to the process. Okay, so our first one, we have the compound inequality where the variable is in between, so we would consider this AND because both conditions are met at the same time. So we have our inequality, and what we'd want to do is solve for x. So I'm looking at that expression in between, and what I want to do is subtract 1 from the middle, but then I also have to subtract 1 from the right and 1 from the left. And we get -4 is less than -2x, which is less than or equal to +8. And still looking at the expression in the middle, I need to solve for x. So we're going to divide by -2. And because I'm dividing by a negative number, notice that we had to reverse the direction of the inequality in both cases for both parts. Because we're going to divide -4 by -2, this inequality switches. We're going to divide 8 by -2, this inequality switches. So let's simplify. And we get 2 is greater than x, which is greater than or equal to -4. Okay, now remember that we always want our inequalities to read least to greatest from left to right. So we're going to flip the entire inequality expression so that the values are least to greatest from left to right. So just take this and flip it completely around like a revolving door. And our solution is -4 is less than or equal to x, which is less than 2. So now when we consider graphing, we have two boundary points. We have the boundary point of -4 and +2. So let's look at the graph. We have -4 for the left boundary point. We have +2 for the right boundary point. Notice that at -4, the circle is filled in because it's less than equal to. And notice that the circle at 2 is open because it does not have the equal sign. And this says our values of x that we would consider are all the values that are between -4 and 2, so that we join the two boundary points and we shade in between. So when the variable is in the middle and it's considered the AND compound, because the conditions have to be met at the same time, we're shading between the two boundary points. Okay, the second one, we had two separate inequalities. So we're going to solve each one separately. So let's take a look at the first one. We want to add 5 to both sides. In the second equation, we're going to add 1 to both sides because here we're isolating y, where we have 3y minus 5. And here we have 2y minus 1. Then we're isolating and by adding 1 to both sides. So simplify. We get 3y is less than -3 for the equation inequality on the left. And here we get 2y is greater than 6. And then we need to continue to isolate the y. So we're going to divide by 3 of both sides of this inequality. And here we divide by 2 on both sides of the inequality. We're dividing by positive numbers, so there's not a need to reverse our inequality signs. Okay, and then simplify. So we get y is less than -1, or, remember these are separated by or y is greater than 3. Let's graph our solution. Our boundary points then will be -1, that's the left one, the leftmost point, and 3 is our rightmost point. So our boundary points, we have less than, so we have an open circle at -1, and we have an open circle at 3. And because it's or, that means the values of y are either less than -1 or the values are greater than +3. So with or, we have our boundary points and we shade to the outside. We shade away. Okay, so if you have any questions, if you need additional practice problems, let me know. But we'll be using these inequalities when we're doing section 2.6, which is solving absolute value inequalities. So the reason we reviewed these problems is because we're actually going to combine the concept of absolute value equations and compound inequalities.